Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life.
Right now, your brain is quietly keeping a biological ledger.
It really is, yeah. Logging pretty much everything.
Exactly. Like it is logging every single ray of sunlight you absorb, every piece of fatty fish you eat, every little micronutrient circulating in your bloodstream.
Even gets recorded on a cellular level.
Yeah, and as a newly published 16-year longitudinal study reveals, the dietary and lifestyle baselines you establish at age 39, they are physically rewiring the structural architecture of your brain at age 55.
Which is just a massive leap in how we understand neurodegeneration.
It's huge. So we are looking at a really fascinating piece of research today covered in Science Alert by David Neild. It's titled, Common Vitamin May Reduce Buildup of Alzheimer's Proteins, Study Finds.
A very telling title, actually.
Right. So the mission of this deep dive is basically to unpack this new research and discover how everyday choices in midlife might quietly rewire our cognitive future. Okay, let's unpack this. Because to understand how we might prevent structural brain degradation, we have to kind of look past the later stage symptoms.
Right, the memory loss, the confusion.
Exactly. We have to look past all that and focus entirely on the microscopic behavior of the proteins involved, right?
You have to. That underlying behavior is where the true narrative of the disease actually unfolds. Because when examining the pathology of Alzheimer's disease, the focus invariably shifts to two main things, tau and amyloid beta.
Right, the usual suspects. I feel like anyone following this kind of research has heard those names before.
Oh, absolutely. They are very familiar territory in neurology, but, and this is the critical nuance here, the issue isn't that these proteins exist in the brain.
Wait, really? I always thought they were just inherently bad.
No, not at all. Actually, a healthy, functioning central nervous system relies on both of these proteins just for, fundamental daily operations.
Oh, wow. So we actually need them.
We desperately need them. Tau, for instance, is an essential stabilizing protein. It binds to microtubules.
Microtubules.
Yeah. Think of them as essentially the internal highways inside a neuron. Tau keeps them stable, ensuring that nutrients and essential molecules can travel safely from the cell body all the way down through the axon.
Okay, got it. So tau is like the road maintenance crew. What about amyloid beta?
Well, amyloid beta gets a terrible reputation because of how it clusters, but in a healthy brain, it's actually thought to play roles in modulating synaptic function.
Interesting.
Yeah, and protecting against oxidative stress. Some research even suggests it acts as an antimicrobial peptide within the brain. The damage only begins when these proteins go completely haywire.
Ah, so when the good guys go bad.
Exactly. They form toxic tangles, they clog up the neurons, and that causes the brain cells to break down, which interrupts all the communication between them.
So it's like having a highly efficient postal service in a city, but suddenly the mail carriers just start dumping all the letters right in the middle of the highway.
That is a great way to picture it, yeah.
Like the mail itself isn't bad. We need the mail. But the massive traffic jam destroys the city's ability to communicate.
That spatial distinction in your analogy captures the biological reality perfectly. Identifying these toxic tangles of tau protein early on remains one of the earliest signs that something in the brain is going wrong.
Even if scientists are still, debating if tau tangles are the root cause or just a symptom.
Right, the causality is still debated, but we know these proteins go rogue long before the memory loss actually begins.
Which brings up a huge logistical problem, right? Like, since these proteins start acting up decades early, how do scientists actually study the early warning signs?
And that leads directly to the methodology of this new study, which is honestly staggering.
Yeah, let's get into that, because they built what is essentially a 16-year biological time capsule.
They really did.
So this is an international study led by neuroscientist Martin David Mulligan from the University of Galway in Ireland. It was published in Neurology Open Access.
And what makes Mulligan's approach so unique is the timeline. The researchers looked at a cohort of 793 adults.
Almost 800 people.
Yeah.
That's a solid group.
A very solid sample size for this kind of long-term tracking. They took blood samples to measure their baseline serum vitamin D levels. And the crucial detail here is that every single participant was exactly 39 years old at the time of that blood draw.
Exactly 39. So they get a perfect snapshot of midlife.
Precisely.
Yeah.
They captured the systemic biological environment at a highly specific stage. And then they just waited.
They just let the clock run.
Yeah. For an average of 16 years, they let normal aging, environmental exposure, and life happen. Then, when the participants were around 55, they brought them back and took brain scans to assess the levels of tau and amyloid beta.
Wait, let me clarify this for the listener, because this is wild. None of these people actually had Alzheimer's when their brains were scanned.
This raises an important question, and the answer is no, they absolutely did not have dementia diagnoses.
They were just healthy 55-year-olds walking around.
Exactly. Instead of looking for clinical dementia, the researchers were looking at neuroimaging markers of preclinical dementia.
Preclinical, so the hidden stuff.
Right. They used abnormal tau and amyloid beta behavior as a proxy. They were looking for Alzheimer's-like brain problems that might just be quietly taking hold in the background.
The silent buildup of those mail bags on the highway.
You got it. And this represents the first time a study has evaluated the association between serum vitamin D and these preclinical neuroimaging markers over such an extended timeline.
Storing data for 16 years just to see how one vitamin impacts a protein fold. That is some serious scientific patience.
This is the only way to catch neurodegeneration in the act, really.
So what did they actually find when they opened this time capsule? Because here's where it gets really interesting.
It does. The study revealed a highly targeted, statistically significant association.
Okay, give us the numbers or, well, the trend.
Basically, the more vitamin D a person had in their system at age 39, the lower the amount of tau protein tangles they tended to have 16 years later.
Wow. So high vitamin D at 39 equals less warp scaffolding at 55?
Exactly. But conversely, there was absolutely zero relationship found between vitamin D and the other protein, amyloid beta.
None at all.
Zero. It didn't touch the amyloid plaques.
That is so specific.
Hey.
It's not just a magic shield for the whole brain. It's a highly targeted defense against tau specifically.
Yes, the divergence there is critical.
But how? I mean, how is vitamin D actually pulling this off? Why would a vitamin from sunshine have any authority over a structural protein inside a brain cell?
To understand the mechanism, we have to bring in context from past research, which the article notes. Vitamin D is actually known to fine-tune the immune system in the brain.
The brain has its own immune system.
Oh, yeah. Very specialized. And the active form of vitamin D crosses the blood-brain barrier and binds to these specific receptors on cells called microglia.
Microglia. Okay, what do they do?
They are the resident macrophages of the central nervous system. So they are essentially the sanitation workers and security guards of your brain.
Cleaning up the debris in the cellular city.
Exactly. They clear away misfolded proteins and dead cells. And when vitamin D binds to them, it upregulates their efficiency. It keeps them in this highly protective, neuroinflammatory reducing state.
So the vitamin D acts like a supervisor for the brain's cleaning crew.
That's a perfect way to look at it. And previous studies on mice have directly backed this up.
Oh, they've tested this on mice.
Extensively. They found that a lack of vitamin D is directly linked to misbehaving tau proteins in their brains. When mice are deficient, their microglial function gets compromised, and the tau proteins begin to detach and tangle at a highly accelerated rate.
That is wild. So basically, if your vitamin D is low, the cleaning crew gets sluggish, and the tau proteins just tangle up and collapse.
Precisely the cascade we see in the animal models.
Which brings us to the most crucial part of this whole deep dive. Because understanding the mechanism is great, but we can't hop in a time machine to fix our blood levels from 10 years ago.
No, unfortunately not.
Right. So what does this all mean for you, the listener, right now?
Well, the lead researcher, Martin David Mulligan, really emphasized this midlife window. He said, and I quote, "Midlife is a time where risk factor modification can have a greater impact."
Because the brain is still relatively healthy.
Right, exactly. The window of opportunity for disease modification is vastly wider when we are younger and cognitively intact. The infrastructure hasn't collapsed yet.
So trying to fix this at age 80 with a supplement isn't going to work.
At that point, the neurons have already undergone programmed cell death. The scaffolding is gone. But in midlife, neuroplasticity is still on your side.
Okay, so higher doses of vitamin D could potentially be this modifiable, treatable risk factor to stave off dementia.
Yes. The researchers suggest optimizing levels by getting extra vitamin D through sunshine, adding more fatty fish to your diet, or taking clinical supplements.
Okay, but let me push back on this just a bit.
Sure.
Because I want to temper the excitement with a dose of scientific reality. I know how the internet works. People read a headline and assume a daily walk in the sun is a guaranteed cure for Alzheimer's.
Right. People love a silver bullet.
Exactly. Can you clarify the limitations of a study like this? Because we need to be careful not to overstate it.
Of course. If we connect this to the bigger picture, it's vital to remember that this study shows an association, not direct cause and effect.
Because it's an observational study.
Exactly. In an observational longitudinal study, you're tracking people living complex lives. So you have massive confounding variables.
Like someone who gets a lot of sun at 39 might also be someone who exercises a lot.
Exactly. They might run outdoors, eat a Mediterranean diet, have lower chronic stress.
No.
While researchers try to adjust for those things, mathematically you cannot isolate the vitamin D molecule as the single causal agent.
So what would it take to know for sure?
To know for absolutely sure, formal testing in randomized clinical trials is required. But that is incredibly difficult.
Because you'd have to track thousands of people for decades.
Right. You'd have to control their vitamin D intake for 16 years, force a placebo group to stay deficient, which is ethically terrible, and then link all of that to actual dementia diagnoses in their 70s and 80s, not just proxy proteins.
Yeah, that trial's never going to happen.
Highly unlikely, yeah. So we have to operate on the best associative data we have right now.
And right now, managing your vitamin D is an incredibly accessible way to potentially stack the biological deck in your favor.
It really is a practical approach to preventative neurology.
Well, I think that is a perfect place to wrap up this deep dive, because it all comes back to that core takeaway. What you do in your late 30s, or really wherever you are in midlife right now, could fundamentally alter the landscape of your brain in your mid-50s.
It's all connected. The choices don't just disappear.
Exactly. And speaking of things not disappearing, I know you had a final thought you wanted to leave the listener with today.
I do, yeah. It just builds on this whole idea of the 16-year biological lag time.
Okay, let's hear it.
Well, think about it. If our central nervous system is silently keeping a 16-year scoreboard of our vitamin D levels, logging literally every hour of sunshine and every piece of fish into a biological ledger, long before any symptoms of cognitive decline appear, it really begs the question.
What's the question?
What other silent, invisible tallies is the body keeping right now? What other subtle nutritional baselines or environmental exposures are currently being logged into your ledger, quietly dictating the quality of your cellular health a decade or two down the line?
Oh, wow. That's slightly terrifying, but also really empowering to think about. The ledger is always running.
Always running.
Well, thank you so much for joining us on this deep dive into the long-term architecture of the brain. We hope this gives you a new framework for thinking about the future and encourages you to keep asking big questions about the small choices you make every day.
Don't forget to like and subscribe for the next episode on While We Were Distracted.